This is tiny. To have a model like this that actually has a sort of chain of thought reasoning thing, it's awesome. The DeepSeek models have been extremely popular lately, and now that they have recently released some distilled models, which essentially we can think of as fine-tunes of small models like Qwen 1.5 or Llama3-1B, we can now actually go ahead and play with some of what makes DeepSeek so popular on small edge devices like the Jetson R1 Nano Super. Which leads me into what today's video is, which is essentially going to be testing some of the newly released DeepSeek distilled models on the R1 Nano Super. I do want to throw in a disclaimer that it is not my intention to become a solely Jetson focused channel. However, being that my most popular video was basically like setting this up for an hour, I figure I might as well cater to those who are likely receiving theirs or have received them and are interested in actually doing some hands-on activities with them. Because this isn't a start to finish tutorial, there will be a few prerequisites that will need to have been completed in order to actually follow along with where we're going to begin. Now, I don't want to leave people hanging, so I have actually covered those in the 55-minute long setup video I did on this. So I will put the link to that in the comments along with the timestamp of what you actually will want to watch. So now that that is out of the way and we are aware of what we need to do to actually get started with this, we can basically go ahead, plug it in, and get going. So we are once again on the Jetson AI Lab website, which you've likely become very familiar with over time, as have I. And I just want to quickly give an overview of what technology we will actually be using in this example. So if we scroll down and click on text generation here, and then go to the side, we can see Open WebUI. And for this demonstration, this is what we are going to be using. Now, I have already gone ahead and set this up as per the instructions here, and also basically what you can see in my full tutorial video for this. But the real benefit of this is that it will actually allow us to pull the model we want from Ollama without needing to actually deal with the Ollama container or anything like that. So it can be a little confusing, and I just want to make note of this, that if you don't actually know how to get back into the Docker container you made, you may just think, okay, I just need to go and run this again. And if you try to do that, it will not actually work, because it will basically be like trying to make a new Docker container with the same name, and it will basically tell you you can't do that. So I am going to minimize the browser, as we will need it later. And then we are just going to type into our terminal sudo docker run, and then open -WebUI. Did I get run? Okay. So we're going to type sudo docker start open WebUI. And then it will basically, from what I see here, it just shows us this. However, once we have done that, we can actually go back to the web browser, which has opened a new. Okay, we can go back to the web browser we had open, and we can just navigate to 127.0.0.1, and that will be port 8080, so :8080, and we can see it autofills in the suggestions here. And if we click on this, you are going to remember that we may have made a user account when we first set this up. So if you don't have those credentials to get back into it, there's like a whole thing, and we're not going to go over that on this video. So fortunately, I do actually remember what I used. And again, these are more of just a formality, so nothing I'm actually typing here is like real, but this is just kind of the way that this web UI does it. And I will click save. And now we can see that we are back into our Open WebUI, and some of the models that I already have for Ollama on this machine show up right here. So we can see that they're all basically just a bunch of Llama 3 variations. Our next step is now going to actually be downloading the DeepSeek model that we want to run. Now, I am going to start simple because one, it's just a smaller download, but two, it actually seems that for the size of this model, it is really rather impressive in some of its capabilities. So we are just going to navigate to ollama.com, and then up here in the search models box, we will click on this. And if you're watching this video kind of like a few days after it came out, it will likely still be that when you click that, DeepSeek R1 is on the top here. So we are just going to click this, and we will see that there are a bunch of different variations here, and we need to select one. So default, it shows us the 7B, which seems to be a fine tune of a Qwen 7 billion parameter model. However, I want to run DeepSeek R1 1.5B as it's a very tiny model, and I think it is pretty cool. So we are going to just select that one. and we will see, okay, normally we would just copy paste this into our terminal to get it to run. However, for Open WebUI, if you go here and click the model dropdown, you can actually search a model. So if I were to start typing something, you can see that if it doesn't find it here, it will actually say pull from ollama.com. So in order to do this, we basically just copy the actual model name as it appears following the run command here. So in my case, or in our case, it would be DeepSeek-R1:1.5B. And if we paste that in right here and press enter, or we can just click this, pull DeepSeek R1 from Ollama, we will see that pulling manifest appears, which means, hey, it actually did find it, and it is going ahead and downloading the pertinent files from Ollama directly onto our machine through Open WebUI. So this just kind of makes it a lot simpler and pretty cool. Now, while it is downloading, it won't take too long, so I'll just probably skip till it's downloaded. But I do want to point out one of two things. The first is that I had read that apparently with some of these reasoning models, specifically from DeepSeek and according to DeepSeek, it seems to be best to just kind of give them the entire prompt the first time. So essentially meaning if I wanted to accomplish something, I have a better chance of getting it to do it correctly if I just kind of tell it everything I want it to do in one prompt. So a more one-shot style approach. Following that, the other thing I was going to mention, I have forgotten. Oh no. Okay. So it was, if you do just run this in the command line through Ollama, which I've actually tried doing on my machine behind me, I noticed that it doesn't actually show its chain of thought. So these are like reasoning models which have a chain of thought, which you can see. So they actually will think while they are responding to you. And we can see that I have managed to talk throughout the entire download. So we basically have the model here and we're going to be able to use it. So you want to go ahead and actually delete this from the search bar here now that it's been pulled and downloaded. And once you do that, you will just see it as a selectable option here in the dropdown. So I will just click this and we will be able to go ahead and speak with it. The 1.5B model is now ready to be interacted with. However, there is one quick thing I want to bring up just for continuity's sake. I needed to reboot the Jetson, and instead of actually typing the command into the terminal to start the container that had the Open WebUI associated with it, I just tried directly going to the Open WebUI URL, and it did load and everything seemed fine. So perhaps you don't actually need to do that. I'm not sure. I suppose you could try it either way and see what works. Just for continuity's sake, I wanted to briefly mention that as a disclaimer, as I don't like to make mistakes or anything or mislead. So with that said, we can just go ahead and grab our 1.5B and we'll just send it a first message. And you may notice I also did download the Llama3-1B variant of this. Unfortunately, that's not going to run. So after we play with this, we will do something else. And for the first time you actually send a message to this, so the Jetson here just rebooted, so it has not actually had the model loaded yet. So it will take a little longer for the first response that you send to be produced. But we can see that we get a response from this little model. And we do see these two things here, which may seem a little more unfamiliar to us. One is a think, which would be think open, and then think close, kind of. If you're familiar with like HTML type stuff, that will be a little more understandable. So in there is what we can consider the inner monologue of the model. So if I type something that is a little more intricate, that requires the model to actually think, it will actually go ahead and populate those thinking fields with its inner monologue. So I've just asked it to, I made up a fake thing, but tell me about the quant program at State Tech University of State, which is a very prestigious quantitative analysis program. So, and we can see here that it is actually going through a sort of inner monologue thought process. And this is really one of the big things that has attributed to the overall popularity and like excitedness that folks have around these models, is that they actually can do this. So I'm not going to read the entire actual output that we see here, but it is actually like pretty cool to take a look at it. So it's like, okay, let's see. The user asked how I am now, which is a common greeting. Then they provided more info about the quant program at State Tech State. And it's okay, so blah, 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 blah. And then we can see here that upon the closing think tag, we actually see its actual response. So, okay, I'm an AI assistant. I'll do my best to help you. How are you doing? provide you, okay, and then it just kind of comes up with a kind of like analysis of what it thinks this program is, with some like generic stuff that you would think to see in like a quant program like Python or R and stuff like that. So it is really quite cool. Now, in keeping with the actual thing we had seen, or I had seen, that I had mentioned about these models working best where one shot is the way to go, I am going to just quickly have it try some Python code. It is not going to work very well, as I have gone ahead and actually tried this on my other machine behind me with the same model to do some Python generation, and it was not usable code, but it did look like it was, but it wasn't. So I've asked it for a Python script to calculate the sum of two numbers. I didn't want to just ask it to make a calculator in Python, as it just definitely would have no chance of working there. So we can see it's just kind of, it's so odd to see like it being like, first I remember this, wait, what if someone doesn't enter a number? So it's actually thought to itself, oh, this, it's just interesting. Like, this is essentially like how it understands that it needs to put like a try except block and exception error handling and stuff. It's just so odd to see, especially from a model that is 1.5 billion parameters, which is micro. This is tiny. To have a model like this that actually has a sort of chain of thought reasoning thing, it's awesome. So, okay, here's our Python script that adds two numbers. Okay, this will work. So solid job. Let's just do and we'll paste it in, write out, and then we'll do Python sum.py, and then we'll enter our first number of 4, then we'll enter our second number of 8, and let's see, fingers crossed. Yeah, so it did, but it's cool, like a 1.5 billion parameter tiny little model just made some form of usable Python code, which I suppose is kind of cool. Now, being that I am unable to actually run the 1.5B, the 8 billion parameter Llama 3 version that you can also see on Ollama, which I will just show to give a little more understanding of my video. I apologize if I'm a little out of it. So we can see if we scroll down here that there is the 8 billion Llama DeepSeek R1. That is the other one that I had pulled, and unfortunately when trying to run that with the Firefox browser open, the Open WebUI, and kind of just the whole desktop environment, it was too much for the Jetson to really be able to contend with all at once, so it kind of froze up. I just want to bring that up because it is maybe possible if you're in a headless setup and you just use Ollama through the command line, it will probably output something, but if you try doing it this way, it's not really going to work. So just wanted to bring that up. Now, the only thing I want to actually do is let's just compare this to another really tiny model that I have on here, which if we do our drop down, we can see, okay, so I have a Llama 3.2 1B. Obviously, it's not a super fair comparison, but I figure let's just try it because why not? So we're down 500 million parameters, but we are just going to see what happens. So we'll paste it in. I'm kind of having fun with these. These are fun. And this will obviously take a little longer to generate the first reply, being that it will now need to load Llama 3.2 1B. Okay, so this is just making a function in Python. So this will work, but you have to actually manually fill in the numbers. So I would have to like fill them in like this instead of what we had before, which was more of like what I asked, which was a script to actually add two numbers that when run will actually go ahead and just do this. So like if I just tried this the same here, I got to stop using the same names for scripts. So if I just try running that, it just adds up the two numbers defined within the script. So it will only work with defined numbers like it would here. So it just prints the sum of these two numbers. So kind of it does work, and I've probably gone way convoluted and stuff, but this is kind of the direction that I went in, so I figure I would try it. All right. To conclude what has perhaps been a more verbose than required video, since I could not get this really working well in Open WebUI with the 8 billion parameter Llama 3, I have not tried the 7 billion parameter version of Qwen that they have here. I would assume that I would also run into kind of overhead issues just trying to run the whole desktop environment as well as the browser and things like that. So there is one other cool thing that I want to show for those of you running this on the Aura Nano Super. If you want to try a powerful model that will actually run within Open WebUI in the desktop environment. So if we change this to the 1.5B, we see, okay, this is a 1.5 gigabyte download. If we go ahead and actually click on these 28 tags here, we will see that we get different versions of these specific models or different quantizations. I think the best way to explain this is, imagine we're looking at a picture and the default one here is, it's the same picture, but it's kind of like a more grainy resolution. So there's not as much finite detail that we can actually see in the picture. But if we see that we have the 1.5B Qwen FP16, we can see, this is 3.6 gigabytes, even though it's still the 1.5B. So think of this as sort of the same picture, but we can see far more detail in it. So essentially, this will just be a better performing, but more performance intensive version of this 1.5B model. So we are basically just going to scold me for not understanding how to use Open WebUI still. But following that, we'll paste it in right here for the search model, and then we will once again just pull it as we did before. And for some reason, we see download cancel. Okay, the file does not exist, so I may have made a mistake. So you actually need to click on that, and then from here you make sure you go and copy what comes to the right of the run there, and then if we paste this in here, then we can see that it was successfully found based on the fact that it begins to actually download this. So we will just download this and run it real quick, but I just kind of wanted to show that. So if you do want to play with one of these models and you don't want to feel like you're kind of handicapped with the 1.5 billion parameter small weak model, you can run the FP16 variant of it, which is bigger and more powerful than the one that we tried earlier. And we can see that the model has been successfully downloaded. And if we just kind of close out of that, we can then go ahead and make a new chat with our newly downloaded full precision version of the 1.5B Qwen. And pretty much we'll just tell me a fun fact about the Roman Empire. Why not? I'm just going to ask it to do that since that was a default thing here. I'm not going to ask it to do more coding, but I just wanted to quickly kind of demonstrate running this one as well, as it is a way to get a model that is a little more performant than what we could get with the default pull and still can be run on our Jetson with the desktop environment and Open WebUI open in a browser and things like that. And we can see that the token speed generation-wise is a lot slower than the other 1.5B, and that can be attributed to the more detailedness of this model, to put it very, poorly. This is slower because it's more powerful. And we can see, though, that it is going through its chain of thought here. Okay, and it's just so funny seeing it be like, where do I start? It's like it's acting as a human would. Well, and I'm not, again, going to read through this, like the whole thing and check. Okay, but we can see a thought, and then its thinking tag has ended, indicating the conclusion of its thought process, and here would be its actual response. And it just tells me about the Colosseum. Okay, I'm not a history buff enough to be able to actually verify any of these facts that I'm seeing right here. But it is kind of cool and just a kind of quick demonstration of running something a little more powerful that the Jetson will still handle with everything else as well. That is really just going to conclude this. I wanted to test these models somehow, but I understand there's probably going to be a flood of just talking heads on the screen, like showing you, hey, it can count strawberry. I don't want to do that. So I figured, being that there is a lot of interest in the Jetson R1 Nano, and it really helped propel my channel somewhere I thought it wouldn't even get to, I figured I would use that and make it something that those of us who have one of these devices can actually follow along and play with. These models are really cool, and if you want to actually get experience with a reasoning model or an intelligent, like, chain of thought model, whatever you want to call it, this is really a fantastic and fun way to be able to do it on a low-powered edge device. So you don't need something beefy or something that's going to draw your power bill to like crazy amounts. These are very cool, fun to play with, and I hope this was somewhat of a educational benefit for those of you interested in this stuff. Thanks for watching, and that'll conclude it.